So I personally am super excited for today because not only is it going to prove out the mechanism, but I will now be able to build a pen for myself. I gave my mother my pen last summer.
Best way to get a Saga, be Grimsbow's mother.
And I haven't had one since. So we need to make parts so that I can have a pen back. Hey guys, welcome to another episode of Saga Saturday. I'm excited about this one because we are fine-tuning the mechanism and finding our tolerance range of what actually the parts want to be in order to perform optimally. Because we did have some issues with the first batch and a lot of bad parts and a lot of things that wouldn't go together. So we got to find our range of everything. So these parts that we got here, Angelo's been cranking these out. This is our button. He just made these in the past hour.
So that is essentially that button right there for that mechanism. So the OD is very critical. The position of this slot is very critical. The surface finish is critical. On the actual production parts, we're going to be polishing this surface where the balls slide and roll, and that way it'll give it a nice feel without any grit to it. So we're tweaking that in now. And right now this is all about testing our fit-ups.
We made these sliders last week, I think. And then a few weeks ago we made these little retainers that clip into the bottom of the button and hold everything in place. But the critical ones are the slider, the button to an extent, and then last thing we got to make today is this threaded sleeve. And then we should be able to make an assembly and see how everything fits together. Now, we made min and max with the tolerances that we believe we need. So this one's slightly bigger, this one's slightly smaller, these are all in the middle. And then we've got the same for the sliders, so that we can put together a worst case scenario. How would that be, like a min and a max? Or
yeah, it depends on how.
Depending on which way you're going.
So we're making our minimum maximum of our tolerance range. And then when we do our assemblies, we stack them accordingly and see if there's going to be any errors with the fit up, if we have a min with a max or a min with a min, and basically ensure that the assembly is going to work with the tolerances that we've given it. And if there's something that doesn't work, we just tweak the tolerances accordingly, and to make sure that we can take parts off, measure them, knowing 100% certain that they're going to assemble together and always feel the same.
Right, so worst case scenario, both small and large, to see how the mechanism clicks, because we're kind of super duper picky about this kind of stuff, and we want it to be great, and we want to be able to make parts with confidence, knowing that we can always assemble them and they're always going to be good no matter what. So you create this range, this min and max, and then we'll be able to make assemblies hopefully later today, if not next week, and then we'll be able to know how they go together. So that's the job today. Next step, make that guy. So while we make new threaded sleeves, there's one process change and one dimension that I want to change. So when we made the sliders last week, I believe in the last episode of Saga Saturday, we worked with that boring bar that comes in, and we slowed down the SFM so that it actually is happy. I have to do the same hack to this to slow it down, because this is heat-treated 17-4 stainless steel. It's very hard. It's like 45 Rockwell, and we're turning it in the hard state. So I've got to slow down that boring bar so that it comes in and it's happy. And then the change that I want to make is possibly make that button sit lower, because it bottoms out there when you click the pen. And because of the internal tolerances of the way the mechanism works, I think this needs to go lower to make us happy. Aesthetically, I like it where it is, so we might, test it lower, but then raise the thickness back up, but keep the mechanism down low. So we're gonna have to play with that, but it'll be an easy test to be able to lower that and see if it does what we want it to do in the mechanism. If so, golden. Step one will be to set up the lathe for making the threaded sleeve. So we gotta change collets, we gotta change some tools, add some drill bits, get it all ready to go. Step two is to make the first part, get it all dialed into size, adjust wear diameters as needed. In step 3, we'll make the changes that we need to make in order to get the button to sit lower. Step 4, as always, profit.
Welcome back. It's Monday. We are dialed in. We're just about to make the first threaded sleeve, so let's see how it goes. So when we're prototyping a new part like this, we run an optional stop, which does one operation at a time. So it's one little button where it'll do just the turning and then pause and wait for you. You can look at it, just the spotting, pause, just the drilling, pause, whatever you need. So we go one by one. Sometimes we'll even go single block, where it's just like one line of code and then one line of code. And then we've also got the rapid feed rates down. Usually my hand is on that while it's making a part, so that the machine doesn't go crazy, because these are very fast, very dangerous machines. And we gotta be as careful. You can see Angelo's hand is on the feed rate knob right there. Oh, I love that thumbs up. This is the part we're making right now. It's the threaded sleeve. The only change I made from the previous program that we ran many, many months ago was slowing down the SFM of the boring bar on this side, which is on the sub-spindle side. We're almost there, not quite there yet. Should be there soon. This thread gauge. So with this thread gauge, we can't really measure a male to a male thread, but what it works for is to measuring a female thread, like that. So we have the green side is our go. That's supposed to go in. Feels good. Red side, which we never painted red, but that's the no-go side. This is not supposed to go in, but it does. Yeah, it does. So this hole is too big, but for now it's fine. So then we can use, if this were dialed in, we could use this as the master to qualify our thread tolerances. We have a part. Fine-tuning all the tolerances and dimensions, and we haven't created a drawing yet for this part, so Angelo and I got to do that. I'm becoming a big fan of drawings now that I've got someone who knows what they're doing. There's a lot of stuff on here, a lot of stuff that's got to be critical, a lot of stuff that matters, some stuff that doesn't. The through hole is just a drilled hole, that's fine, but some stuff really matters. So we need to know what to measure, how to measure it, what the tolerance is, min-max, and go from there. Go. We're transferring one button out by sliding a new one in the bottom and the new one in the top. That way the balls don't fly all over the place. Sweet! Because there's 3 ball bearings in there under spring pressure that want to escape. I can finally make a pen for myself again. Very excited. We have a couple clips here that we had from before.
So I looked through and I tried to figure out what number I wanted. There's a number 34 because I was 34 years old last year when I first created the pen, so I'm very excited. 34 will be my new number. Process control is really tricky because we've got parts everywhere. Some from like 6 months ago, some from a couple weeks ago, some from now. So which one's good, which one's bad? We really need to just kind of throw away the bad ones, or at least mark them really well.
Alright, so that's a threaded one.
Sweet. Oh, that one's
there. I need a tip and some inserts.
Sweet. Some ink. Tip spring.
Custom tip springs.
Custom. We had this awesome old guy, just one town over, make these for us. Eventually we'll go to his shop and we'll film the process of how he does it on this amazing ancient equipment. Very cool stuff. And that concludes this episode of Saga Saturday. I now have a pen, number 34. Went for a random color scheme depending on what parts we had. I actually like the nickel, aluminum, bronze, gold, silver, titanium clip, blue body, and a silver tip with the stainless button and threaded retainer. I love it. Thanks for watching, guys. Bye.